As I mentioned before, Fabric Decorator is packed with different tools to help you with your creativity. Now, one of these tools is called Shader Attributes. And in Shader Attributes, we have something called Sample UV Coordinates. Now, this basically means that I have, say, for example, a UV here. We have UV map concept, and I've used this image of the Great Wave of Kanagawa to create sort of my waves based stuff, and I can transfer this UV map concept to my gems here. So for example, if I select my gems and if I come here, we have sample UV coordinates and my UV to sample from the object we are transferring our gems to or patterns to. So this dress proxy, we have UV map concept and the attribute name for it is UV sampled. So if I go to my shader editor and if we go to the render view, not on the 2D view, it doesn't work with the 2D view. So if we come here, you can see that I have these gems. Now, if we check out our attribute UV sampled, you can see that we have the UVs of UV concept on these single gems. And this is set to instancer. You might have to change it to geometry based on what you're doing. And then I'm taking the texture of those waves to say, for example, these are the blue gems and these are the white gems, and I'm turning it to a mask, a black and white mask, to then mix between blue gems and white gems. And as simple as that, I've transferred my UV concept to UV sampled for the gems. The other shader attributes work like this. For example, I've selected this moon here and I can say search for attribute in my shader editor. You could simply copy and paste it here. And if we check out factor, for instance, and set this to instancer, you can see that I have a factor, a 0 to 1 factor. For instance, it's most obvious on this specific spline. You can see that it starts from 0 and goes to 1, and this is per spline. So I have a 0 to 1 factor per spline. I can use this to color my objects, for example, like this. I can use this to color them or do really anything I want with it. We have something called per spline index, which is the index per spline. So we could use this to see what it does. It goes from 0, 1, 2, 3, 4, 5, and it does the same for every spline. And we could use mass set to modulo, a value of 2, for example. And you can see I have created this sort of every other mask. I could also do 3 or 4, and you can see how our masks are being generated. And I could also do a greater than to make sure it's a perfect 0 to 1, 0 and 1 mask. Then we have a spline index, which is the index of each spline. You can see it creates a 0, 1, 0, 1 spline index. Now in this case it's actually 4, so making this 2 is going to make it 0, 1 for splines. Then we have random float, which is simply just a random float number that I can use to create, for example, different colors. Let's make this, right now it's set to linear. Let's make this HSV, make this far. Let's also choose some other colors, say red, and this one will be blue. And if we connect this here, you can see that we have created this sort of rainbow effect with the random float. Another very useful tool inside of Fabric Decorator is called Fabric Decorator Distribute Points on Faces. What this does is very similar to what Points on Faces does. So we can use a base for our points. In this case, I'm using the dress.still. And then we can choose a density attribute, which is basically a very simple vertex group. We can paint our vertex group inside weight paint mode, or just select an area and assign it to that vertex group. And we could set the density attribute to, for instance, in this case, it's a sleeve mesh 2. And then we could choose a distance calling. Basically, the points closer than 0.005 meter are going to be removed so that we don't have any overlaps. Then we have seed, which is obviously going to change the distribution. We have radius attribute, which we could disable to just use a radius of 1, or we could drive the radius by our weight paint or our vertex group, which in this case you can see the size or the radius of the points on the lower half of the sleeve is much smaller than the upper ones. And then we have min and max, which is the radius minimum and maximum. We could invert this very simply, just like that. Now we have larger ones on the lower half of the sleeve and smaller ones on the upper half. And it could be any number, obviously, just to make sure we are not getting any weird results. We have also something called circle packed. This circle packed only uses a UV object, so this is very important. And then what it does is basically, for instance, if I make the distance calling 0, we are going to have much more points generated, yet they do not overlap. Our density is right now 100,000. Our seed is 0. We don't use the attribute, it's just randomly changing the size of these points. And then we have something called packing. This packing is what's making these points not overlap with each other. If I make the iterations 0, you can see that they are overlapping with each other, and that's the default distribution. If I make this 32, you can see that it starts to distance them from each other and make sure they are not overlapping. It's not removing anything, it's just making sure they do not overlap. A value of 256 is actually very good in most cases to make sure there are no overlapping. Then we have precision, which is the precision of this packing method. We could make this 0.01 is going to be needing more iteration to make sure it's not overlapping. But a value of 0.02, again, in this case is actually more than enough. So let's make this 256 and take this back to 0.02. Then we have radius threshold, which makes sure the smaller ones and the larger ones do not overlap. We could make this 0.01. And you can see now the smaller ones are just as close to the larger ones as the larger ones to the other large ones. And this was distribute points on faces. Now there are of course also lots of other tools and features that we have already discussed in other videos, so you can watch them as well.